All right, chapter 6.
Can I go grab my notebook?
Go quick. So with naming, the first, 3 notes on this you don't really need to write down, just a quick thing. So with naming, you got to remember, first thing is that there's about 100 elements plus. So you can get millions of CMPDS as compounds, millions of compounds. So we need a system, and that's what you're going to be learning as a system. Again, those 2 notes not important to write down. This one, just a reminder that noble gases don't really bond into compounds. Chemists are starting to force them into compounds, doing some tricks on them, and you are getting compounds, but you usually won't see these when you're naming things. Okay, so those first 3, just an overview of some things that you need to be aware of, things that you should be writing down. First thing, what does monatomic mean? Because that's going to come up today and at other times as well. Monatomic means you have one type of atom. So the root word mono, you drop the O on mono and call it just mono or monatomic instead of monoatomic. But mono means one. So if you have a monatomic ion, it's an ion that has one atom in it only. If you have polyatomic ions, how many atoms are here? These are all polyatomic ions.
More than one atom.
More than one. Okay, it's usually or 2 or more, however you want to say it. So polyatomic, poly means many. It's just 2 or more. Okay. And when I say polyatomic ion, it's ions that have more than one atom, and of course the ion part means there's a charge. So monatomic, polyatomic, know that. It'll help with some of the terms coming up. So atom, remember what an atom is? So an atom is just an electrically neutral, smallest unit of whatever it is you can have, an atom of copper, an atom of nitrogen, whatever it might be. So why is it electrically neutral? Because the protons and the electrons match, so they cancel each other out, which leaves you with no charge overall. How do you get an atom to have a charge? What do they have to gain or lose? Electrons. And then it's not an atom anymore, technically. Then it's a what? An ion. So remember ion. So this is old stuff, but good to get back into things. So an ion is an atom, but now, or groups of atoms, which is polyatomic now, which are the 8 that you have to get memorized very soon. And you'll have time to work on them today. Homework will probably take 20 minutes, and you should have more time. So start working on them today. So ion, atom, or group of atoms with a charge. So how do you get that charge? You already said it. By the gain or the loss of electrons. So that's nothing new, just a quick review of things. And while you're finishing up this, looking at the schedule, you can see a bunch of red on the next 3 days after today. And that bunch of red is likely quizzes, just little mini quizzes, 10 or less points. Tomorrow will probably be 10, we'll see, 5 to 10, somewhere in there. Tomorrow I have a monatomic ion quiz, likely. Monatomic, how many atoms are there going to be? Just one. So an example, a monatomic ion. Actually, I got some coming up here. So here's a monatomic. Anions, remember, are the negative ones. So anions or negative ions end in IDE. And I'll give you an example. So I say example, Cl. Is Cl an ion? Why is that not an ion? There's no charge. So Cl, that on its own, you just say it's chlorine. Okay. And then if you look where Cl is on the periodic table, what will Cl do with the electrons? Gain or lose? Gain. How many? So what's its charge? Cl1 minus. That is no longer chlorine. Its base is chlorine, but how do you name this now? Yep. So you just change the ending to I. So it's usually the first syllable of whatever element. So chlorine is chlor, and then IDE. So chloride. And when you see IDE, start thinking negative. It's not always a negative thing, but usually a negative ion like that. Okay. And then some other ones I know people have trouble with. So here's an example of a quiz question that you'd get tomorrow. Little pop quiz. P3 minus equals blank, and you'd have to fill it in. Its name, basically. So what is that? Phosphide. So you just take the first syllable. A lot of people say phosphoride. No, it's just phosphide. Okay. Or another example for quiz, nitride equals blank. So if I give you the name, you got to write the symbol in charge. What is it? N3 minus. Is it N3 minus or 2 minus? 3. What if I said this? Nitrogen, this will catch some people, equals blank. With what charge? No charge. Nitrogen is just an element. Okay. And then you have positively charged ions, which are cations. So cats are positive here. So cations are, as far as naming goes, the name of whatever it is you're talking about, followed by ion. So an example here is Na. What is Na? Sodium. And that's it. Can sodium form an ion? Yep. Sodium is element number 11. So gain or lose electrons? Lose. How many? 1. So the charge is 1 plus. So name that now. It's just sodium ion. Not sodide. Sodium ion. So positive one's the name, followed by ion. So that could be an example of a quiz question. Na1 plus equals blank. Or, yep. Or calcium ion equals blank. Ca. It's telling you it's an ion, so you look where Ca is, it would lose 2 electrons and be 2 plus. So that will be tomorrow. Anything. So where do you get it? You got to use the periodic table. So these polyatomics, not tomorrow yet.
Yeah,
But coming up
like
fast.
BI or something. Yeah.
No. No. Just things that can have charges. Okay? So this table, it's up to you whether you want it in your notes or not. There's a couple things that'll help. It was in the reading guide as well. It's basically an overview of things to remember. What's that? Yep. So CMPDS right here is compounds. Couple things I want to add to this before we fill it in. Ionic. In an ionic compound, what kind of bonding is there? Ionic. So in an ionic compound, there's ionic bonding. In a molecular compound, molecular means you have molecule, which is covalent bonding. So those are a couple things that might catch some people, even though they're fairly straightforward. So what's the smallest piece of an ionic compound that you can have? Like NaCl. That's 1 what of NaCl? It's not a molecule. It's on your exam. Think. Formula unit. So formula unit is the smallest piece of an ionic compound that you can have. For a molecular compound, that's like water is molecular. H2O is a molecule. What kind of elements do you have in an ionic compound? A what? Non-metal and what? Nope. Metal and a non-metal. Usually. And I put usually there. The bigger thing is that you usually have a cation, so it's usually a metal cation, and a non-metal anion. So a positive and a negative, a cation and an anion. And again, usually that cation is a metal, but not always. In a molecular compound, that's the non-metal bonded to a non-metal. So it's 2 or more non-metals. Physical state, we just went over this in the reading guide. An ionic compound or an ionic bond is very strong. So at room temperature, they're usually solids. Whereas molecular compounds, not necessarily as strong, but like diamond is molecular bonding, that's very strong. But so as far as bonds, a little bit weaker, so you could have a solid, a liquid, or a gas at room temperature. And then the melting point here, I'm just kind of looking for high or low melting points. So I just said ionic bonds are very, very strong. So they're going to have a high bond dissociation energy. It's going to take a lot of energy to break that bond. So the melting point for ionic is going to be high or low? High. Relatively high, greater than 300 degrees Celsius, so 3 times the boiling point of water. And a molecular compound is just going to be opposite. They tend to be lower melting points. Not always, but they tend to be. And by lower, that's less than 300 degrees Celsius. So that is section 6.1. We're going to move on to section 6.2. I used to do 6.3 with this as well, but I'm going to pull off and do 6.3 on its own so that you hopefully really get it down good. Again, this whole chapter 6 is very, very important for the rest of the semester. This can make or break you. So chemical formulas. Molecular formula, we kind of already talked about it, but it's the number. Molecular formula includes the number and the kinds of atoms in a covalent compound. Covalent means it has covalent bonding, which means it has non-metal bonded to non-metal. Okay? So these are just some multiple choice potentially. So here's a couple examples. CO2 and C6H12O6. Why are those covalent compounds? You can look at them real quick and say, yep, those are covalent bonds. How do you know? Like in CO2, how do you know this has covalent? What's that? Non-metal to non-metal. Or here, non-metal to non-metal to non-metal. And I got this in another class, but hydrogen's a metal, isn't it? Because it's on the left side of the periodic table. You got to use common sense there. Hydrogen's a gas, it's not a metal. Okay, so it's a non-metal. You had to do this in the reading guide. We'll do it once here. How many of each type of element are there? So how many of these? One. What is this? Carbon. So there's one carbon. Usually you'd spell it out. I'm just going to shorten it up here. And then there's two oxygens. You might get this. What do you call this little two? A what?
Script.
Kind of script. Subscript. There's superscripts also, but this is a subscript. So I might ask questions about what a subscript is used for. It's to tell how many of each element there are. The C, there's not a subscript after it, but there is one C. It's right there. And then C6H12O6, 6 carbons, 12 hydrogens, 6 oxygens. So that's pretty easy. So there's molecular formula, and then with ionic compounds, you have a formula unit. You've had this definition before, but it is important for the rest of the year here, so we'll go over it one more time. It is the simplest whole number ratio. That's very important that it's whole number here of ions in an ionic compound. And again, ions have a charge. Ionic compound is usually a metal cation bonded to a non-metal anion. Usually. Couple examples, few examples. So you have NaCl, one sodium, one chlorine, definitely a non-metal and a metal bonded together. Calcium, a metal, chlorine, a non-metal. Then you get to NH4NO3 here. So N, non-metal. Hydrogen, non-metal. Nitrogen, non-metal. Oxygen, non-metal. What kind of bonding is that? All non-metals. Kind of bonding.
Covalent.
Usually you want to say covalent because all nonmetals is covalent. Except, look at this and look at the list on the board here. You recognize anything that's in that compound, NH4NO3? That's in here. Should. NH4 right here with a 1 plus charge. And then O3, 1 minus. So 1 plus and 1 minus is neutral. So this is a neutral compound. You need a neutral charge overall. There's 2 ions. There they are. This is your cation, positive, and this is your anion. So you have to watch out for this ion because it's all nonmetals and it'll trick you and you think, oh, it's covalent bonding because it's all nonmetals. Nope. It's ionic bonding because you have a cation and an anion. Okay? And then as far as numbers, 1 sodium, 1 chlorine, 1 calcium, 2 chlorines. We'll get something a little bit trickier here. Let's say you had NH4, 3, PO4. And I want to know how many of each element are there. We'll start with the easier ones. How many oxygens? 4 oxygens. How many phosphorus? 1 phosphorus. How many nitrogens? So a lot of people say, is it 3 or is it 1 or is it 7 or how many hydrogens? Is it 3 or is it 7 or is it 12? Well, here's what you got. 3 ammoniums look like this. There's 1, there's 2, and there's 3. How many nitrogens are there? 3. So 3 times 1 is 3. How many hydrogens are there? 8, 12. So 3 times 4 is 12. So you multiply those. So what this means is there's 3 of everything in the parentheses, or 3 ammonium ions. Okay? So watch out for that. Easy points that you don't want to lose. Okay? And then that's it for today. So the homework probably take you about 20 minutes. Most people take about 20 minutes on this one. And then you should start working on your ions. Ions, the polyatomics on the board, flashcards are probably the best way to start. Look at them every so often, 5 minutes here and there.
I think you're missing a C in lunch.
Definitely write them out. 'Cause you don't want to get to a quiz and try to think, oh, what was on that flashcard. Write them out a bunch of times. And again, you will be seeing those throughout the year.